Hello, math friends. How are we doing today? We are here and we are ready to start a brand new module, a brand new unit today. And it's a fun one. It's one of my favorite units. This unit is on area. So finding area. And just to do like a little intro of what area is finding how many square units it takes to fill up a shape. So for example, if I have this Post-it note and I want to find the area of this Post-it note, I could find out how many square tiles it takes to fill up this Post-it note. So that's pretty neat right there. That goes 3 straight across, nice and even. Okay, and then I'm going to go keep putting them right together, just like that. I've got room for some more. Okay, there we go. That is pretty perfect, isn't it? So how many square tiles did it take me to fill up that Post-it note? Let's count together. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it took 9 square units. So each one of these would be a square unit, 9 square units to fill up this Post-it note. So the area of this Post-it note would be 9 square units. Okay, so that's what area is. So we use squares basically to figure out how many square units it takes to fill up a shape. So if you think of a classroom and the floor of a classroom, what do you see on the floor of a classroom? If you're at home right now learning, maybe you don't remember, or like in your kitchen, if you have tiles in your kitchen or your bathroom floor, those we can think of as square units. And you would count to find the area of your kitchen or the area of your bathroom or the area of the classroom. You could count how many squares fill that floor, and it would be that many square units, just like we did with a Post-it note on a much smaller scale, right? So it took us 9 of these squares to fill up the Post-it note. So the area of this Post-it note is 9 square units. So that's what area is. We figure out how many square units it takes to fill up a shape. Now there's different units. This particular square, these are square inches because the sides of this square is an inch. If I were to measure each side of the square, each side would be an inch. And I have these little squares right here. This is a centimeter. Okay, so each side of this one would be a centimeter. Obviously, an inch, the square inch tiles are bigger than the square centimeter tiles. Would it take me 9 square centimeters to fill up that rectangle? No way. It would take a lot more than 9 of the square centimeters to fill up that rectangle, right? Or not rectangle, but the Post-it note, which is actually a perfect square, right? Because all the sides are 3 square units. So that's what we're working on in our new unit. So it's super fun. It goes along with what we've worked on in math already with multiplication. We'll even be doing some division. We have our side lengths. The other fun and easy thing that we've already learned is that there are 3 rows. 1, 2, 3. This is like an array, right? Which we know how to do. So since there's 3 rows, 1, 2, 3, and there's 3 in each row, 1, 2, 3, I can say for my multiplication sentence, I can say 3 times 3, which I know is 9, right? Which we also said that is the area of that Post-it note right there. So yes, we can count squares, we can multiply side lengths. Those are both great ways to help us to find the area. So that's what we're diving into today. So I'm going to dump the Post-it notes and let's look at our objective for today. So today we are decomposing and recomposing shapes to compare areas. So decomposing means taking apart, recomposing means putting it back together. And I'm covering up our I can statement. I can change shapes to compare areas, and we can not worry about that. One thing, as you can see, I do have some math manipulatives. So if you have the square tiles like this, I know some of my kiddos have these tiles. I sent these home. You may not have these square tiles, but maybe you have, I know when we were making arrays and stuff, we use cereal. That doesn't work anymore because we need actual square units. So you may have paper square tiles that were sent home that maybe you got in a pickup. You should have some square inch and square centimeter tiles. And worst comes to worst, if you don't have those materials yet, then just watch and follow along. So when we were filling out the Post-it note, I dumped it all, but I want to bring it back for a minute. We had it all filled up with no spaces in there, right? So I had 3 in each row and there were no spaces. It was all filled up. So I knew that way that it was 9 square units that filled up this Post-it note. What if, so it's pretty perfect, right? There's no spaces, there's no gaps. It's not perfect. I'm trying to squeeze it in there pretty close, but these move pretty easily, but it looks pretty good, right? Okay. What if it looked like this? What's wrong with this? And I say, okay, there, that's filled up. It's mostly filled up. So I think that the area of this Post-it note is 6 square units. What's wrong with that? Is that correct? No, because there's spaces and gaps. So we want to make sure when we're finding area that we don't leave spaces and gaps, because if we have spaces and gaps, we're not finding a true area. Okay, so we do not want spaces and gaps. Now let's try this. What if I did this? What am I doing now? What's wrong with that picture? Some of them are overlapping, right? So in this row, I have 3. This row, I have 4. And this row, I have 3, but they're not overlapping. Maybe I'll just stick another one on there. So I have 4, 8, 9, 10, 11. So I would say that the area of this is 11. Is that correct? It is not. So when we are finding area, it needs to be nice and neat and perfectly together. We don't want spaces and we don't want gaps. Okay. So now I can dump my Post-it note. Okay. And remember, you want to have paper square tiles, or if you have some of these will count for our square inches, but you're also going to need square centimeters. So you need the little ones. And you will need your lesson 2 problem set for today. So if you need to pause your video and get your materials, and you'll need a pencil, of course. And more specifically, you're going to need 12. You're going to need 12 of the square centimeter tiles, and you will need 12 of the square inch tiles. Okay, so if you need to pause it and grab your materials, go ahead and do that. And then I'll meet you right back here. All right. So if we look at the directions, it says use all of paper strip 1. So we're not using a paper strip per se. We're using, like I said, your 12, you're going to cut out and get 12 of the tiles, okay? Or if for my friends that have these, you need 12 of these, okay? And the first one says square inch tiles. So these are going to be your bigger ones. So these are our square inch, and then we would have the smaller paper tiles for the square centimeter tiles, okay? So the first one, we're using 12 square inches. So you want to have 12 of these puppies. So 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 of them, and I want to make 3 different rectangles, rectangle A, B, and C, and they are going to have 12 square units in it. So I didn't even mean to, but I put my first one. How many rows do I have in this kind of messy array here? I have 3. And how many are in each row? 4. I didn't even mean to do that. So I have 3 rows, but the way that it's right now, is that good? What's wrong with it? If we're trying to find the square, if we're trying to find the area, it's all spaced out and some are actually overlapping. So Mrs. Gorilla just said that's a no-no. So we want to make sure that if we're going to make this with 12 square tiles, to have an area of 12, we want to have them all together. Try to make it so there's no gaps and that we're not overlapping. Okay, I can see tiny little spaces, but that's okay. You get my picture, right? Okay, so we have 3 rows, 1, 2, 3, and there's 4 in each one. So a kind of a easy trick, like if we know that the area that we want to find is 12, I can say, it's probably going to mess up my picture there. So what times what equals 12? And we already did that one kind of by look. I have 3 rows, so I know that 3 times 4 equals 12. So I don't want to fill that all up because I want to be able to draw it because this is asking me to draw. So to draw what I have, I hope you made that with me too. So with your square inch tiles, I want you to make a rectangle that has an area of 12. That's 12 square inches. So with your 12 tiles, okay? And then we can write that number sentence. And then for the drawing that goes with it, it's going to have 3 rows. So to make my 3 rows, I'm going to make 2 lines going this way, kind of like what we learned when we make tape diagrams, right? Because we always have one less line when we're making a tape diagram. And then how many are in each row? 4. 1, 2, 3, 4. So how many lines would I make down for the columns? 3, right? To make the 4. So I've got 1, 2, 3. And try to make them kind of the same size. I know this one looks a little bit bigger, but that's okay as long as it's pretty close. Okay, so I have 3 rows with 4 in each one. So that kind of, I made a drawing to match my picture. So altogether, how many square tiles do I have here? I have 12, right? 4, 8, 12. So the area will be 12 square, and we can put SQ as an abbreviation for square. And then we can say square units, but these are square inches. So I'm going to put IN to represent inches. So my area is 12 square inches. This abbreviation means 12, and this one means inches. So 12 square inches is my area. So this is kind of fun too because we get to use this new label, which is new for us. We're getting to be older mathematicians. Okay, so now we want to make, and if you need to pause at any time, feel free to pause it if you're still working on your creation. We want to make another rectangle that has an area of 12, and it needs to be a rectangle. So using these 12 tiles, I want to think to myself again, what times what equals 12? Pause your video and think about that for a minute. What else times what else could equal 12? And I need to do this 3 times. So I already did 1. So I'm going to do it again here. Blank times blank equals 12. So pause your video and see if you can come up with 2 different equations that equal 12. Okay, so pause and then come back to me. All right, what do you think? What do you think? So here's what I was thinking for my next one. So I can jumble up all my tiles. And I'm thinking I'm going to make 2 rows. Here's another way that you can do it. If you're stuck with your number sentence first, just start making rows and see if you can use them all. So there's my 2 rows. And I'm going to keep putting 1 in each row until I get to my total of 12. So that's another strategy. So I'm at 8, and I had 12 to begin with, so I know that I'm not going to go over my 12 mark. So I just kept those same 12 tiles, and I just felt that works. See, this works because they both have equal amounts in each row, right? So try to make sure that when you're putting yours together, that it doesn't have gaps or overlaps. Okay? So if you need to pause it and make it, feel free. So if I'm going to fill in my number sentence here, how many rows do I have in this picture? I have 2 rows. And how many in each row? 6. So 2 times 6 equals 12. And I want to draw that picture. So I'm going to make it a little skinnier than this one. There's only 2 rows. I'm going to put 1 line down the middle because there's 2 rows. And I want 6 in each row. 6 in each row. So how many lines would I make down for the columns? 5. Since I want 6, I'm going to go 1 less. I'm going to do 5. And even if we look at it here, right? If I put this back together, I've got 1, 2, 3, 4, 5. So I can use that to help me too. So 1, 2, 3, 4, 5. Try to make them look as equal as possible. You don't need to pull out a ruler and measure anything, but just try to keep it as close to the regular, to being equal as possible, since that's what you want to do. Since when we're doing with square units, square inches are all the same size. There's 2 rows, and there's 6 in each one. I can put that times sign in the corner. Remember doing that too in our first unit and our last unit? Okay, so what's my area here? 12 square inches again, right? Because the total is 12. So 12 square inches. Okay, if you didn't come up with one for rectangle C yet, you can pause it and see what you come up with. You can play with your tiles. You can test out different things. Now I could make, I already did 3 times 4. Maybe you might think of doing, they're falling apart on me, 4 rows of 3, right? That works because I can just flip-flop these 2 numbers with a commutative property, right? So instead of saying 3 times 4 equals 12, I could say 4 times 3 equals 12. Instead of saying 2 times 6 equals 12, I could flip-flop and I could say 6 times 2 equals 12. But for C, I want to see if we can come up with completely different numbers in our number sentence that we haven't used yet. So I don't want 3 rows of 4 or 4 of 3 or 2 rows of 6 or 6 rows of 2. Did anybody come up with anything different? Here's one, and you maybe already found this, so that you could always do to get that answer. We could always do 1 times that number. So 1 times 12. Did you come up with that? Good. That's one that a lot of people, we just forget about a lot. We don't think about that. But it's almost so easy that we forget about it, right? So if you thought of that one, awesome. So 1 times 12 means that we want 1 row of 12. So 3, 4, 5, 6, 7. This is not even going to show all the way up in here. I don't even need to count them because I just had my 12, right? So I know that once I finish using them, that it will be 12, but I'll count it once I have it done just to make sure. Oh, maybe it will all fit on there. Yeah, you can. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my square units for that. Okay, so it's really long and skinny. So when we draw this one, I won't be able to make it truly as long as it really is. Okay, but I'll make it that long right there. And it has 12 pieces. So how many lines in it? 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So kind of scrunch those together there. Okay, and there's 1 row times 12 in each row, which gives us that 12. So this is 12 square units. We want to try to make sure, right, that they're close together. We don't have gaps. We're not overlapping. Okay, and what's my area there? It's still 12 square inches. It would still be 12 square inches, right? So all 3 of these rectangles that we created, rectangle A, rectangle B, and rectangle C, they look different, right? They look different, but the areas are all the same. So any of these rectangles, if you take them apart and then put them back together, no matter what, it still has 12 of those square tiles, 12 of those square inches. So they're all the same area. They just look different, which is something important for us to think about with area. What do we think? Fun? Good. So I definitely don't want you just to be sitting and watching. We learn so much better with math and we retain it if we're actually making the rectangles and we're using those manipulatives to help us to create. So I definitely want you to have those, the manipulatives. So if you got the papers from your teachers, make sure please to cut them up and use them because that helps you so much more than just sitting and watching me on the computer. All right, moving along. So number 2 says use of all paper strip 2, which we're not using these paper strips, right? We have our own things, or you're cutting up your paper, to cut into 12 square centimeters to complete the chart below. So now you have your paper tiles that are centimeters. So here was the size of your square inch papers. Here is the size of your square centimeter tiles. We still want 12 of them. Okay, so here's that. We still have 12 of them. So we want to make 3 rectangles that have an area of 12 square centimeters this time. So for rectangle A, could we still do 3 times 4 equals 12? Absolutely. But instead of, and I'm going to show you this, and you do this too, rebuild that 3 times 4 rectangle at the top of your paper with your square inch tiles. If you need to pause it to do that real quick, you can do that. So rebuild that rectangle at the top of your paper with your 12 square inch tiles. We had 3 rows of 4. Okay. And once you have that done, I want you to make it again down below, but we're using our square centimeter tiles. So 3 rows of 4. These aren't going to fit together perfectly for me, guys, because these are not like flat. They are like the linking cubes that I'm just using to show you the centimeter size. But let's just pretend that there's no gaps in there. Can we do that? All right. So there we have 3 rows of 4 there. Whoa, look at that difference, right? Here's 3 rows of 4 with square inch tiles, and here's 3 rows of 4 with square centimeter tiles. So they both equal 12, but are they the same? There's a definite difference in size. If I move that right up there, kind of still together. So my drawing for that, we'll try to like make it small. So since there's 3 rows, I want to make 2 lines, 2 horizontal lines, and then there's 4 in each row, so I'm going to make 3 vertical lines. So 3 times 4. So it still equals 12, but are they square inches? No, they are now square centimeters. Okay. If you need to pause it and finish that up, go ahead. So we're still I'm not gonna completely do all these because we're not gonna rebuild them. You definitely can. This would still be 2 times 6 equals 12, and we could still do 1 times 12 equals 12. Okay. And if you rebuild, we can do it real quick. The 2 times 6, there's 2, 4, there's 3 in each row, 4 in each row, 5 in each row, and 6 in each row. So that's definitely smaller than what we had up there because the centimeters are way smaller, right? So we could redraw that again. We'll just do it nice and small. 2 rows. So 1 line to make the 2 rows. And then I'm going to do 5 lines down to represent the 6 in each row. And then that still would equal 12, just like we did for 2 times 6 above, but it's not 12 square inches, it's 12 square centimeters. And same thing for this one. So if I just take those 6, I did it without completely taking it apart. There's my 1 times 12. There's 1 row of 12, and it would just be long and skinny, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would still be 12, but now it is square centimeters. So what's the difference between using the square inch tiles and the square centimeter tiles? Square inches are obviously quite a bit bigger. So if we're building with square inches, it's bigger. If we're building with square centimeters, it's smaller. Okay, if you need to take a few minutes to pause your video and finish that up, if you want to build some other rectangles and find some different areas, feel free to do that. It's good practice. Okay, And when you're ready, you can unpause and look at the other side. Okay, so if you're back with me, number 3 says to compare the areas of the rectangles you made with paper strip 1, and paper strip 1 was the square inches, and then paper strip 2 is the square centimeters. What changed? Why did it change? So square inches are bigger than square centimeters. This is what we talked about on the other side, right? Now we're just kind of putting it into words. Square inches are bigger than square centimeters. Centimeters, I'm ahead of myself. Square inches are bigger than square centimeters, comma. So the rectangles made with square inches are bigger, right? That's exactly what we said on the other side. And we can easily see that, right? There's our square inch tiles, and there's our square centimeter tiles. So if it's made with square inches, it's definitely going to be bigger than any rectangles that are made with square centimeters. Okay. If you look at a ruler too, you can look at a ruler and see that the inches are bigger than centimeters. So, but we can see that easily too right here with our square tiles. All right, if you need to pause it and finish up with number 3, you can sure do that. Just make sure that your sentence begins with a capital letter and that it ends with a period. Okay, number 4, put your pencil, your finger on Maggie and read with me, please. Okay, here we go. Maggie uses square units to create these 2 rectangles. Do the 2 rectangles have the same area? How do you know? Okay, so let's look at shape A. Couple different ways we can find the area. We could just count the tiles, right? So we've got 1, 2, 3, 4, 5, 6. So this would be 6, and it doesn't tell us if they are square inches or square centimeters. So if it doesn't tell us a label, we just put square units. So it would be UN for units. The other way besides just counting, I can label my side length. So I have 3 rows, just like when we do arrays, right? There's 3 rows. And there's 2 in each one. And we know that 3 times 2 is 6. So the area of that rectangle is 6 square units. If we look at shape B, okay, let's count the tiles first. There's 1, 2, 3, 4, 5, 6. It's still 6. So again, we don't know. It doesn't tell us if it's rectangle or if it's square inches or square centimeters. So we would say square units. And I could also label my side lengths. There's 2 rows with 3 in each one, and 2 times 3 equals 6. Okay, so let's see. It says, do the 2 rectangles have the same area? Do they? Yes, they do. And it says, how do you know? Because they both equal 6. So yes, comma, because they both have, we'll say they both have 6 square units. They both have 6 square units, because whichever way that we did it, if we just counted the square tiles or we multiplied the side lengths, they both equaled 6. So yes, because they both have 6 square units. Okay, again, if you need to pause and finish up, feel free. And we're on the last one. I feel like this was pretty fast today. Okay, number 5 says count to find the area of the rectangle below, then draw a different rectangle that has the same area. So it says count to find the area of the rectangle. So I'm going to count my tiles. I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this would be 8, and it doesn't tell if it sits, that looks like centimeters, but since it doesn't say, we'll say square units. And then it says to draw a different rectangle that has the same area. So I want to think, what else? What times what equals 8? So this was 1 times 8, right? Equals 8 because it just had 1 row of 8. Can you think of 2 other numbers that you could multiply to get 8? And you could even take out your tiles and play, right? You could take out 8 tiles. 1, 2, 3, 4, 5, 6, 7, 8. And maybe I'm going to try just having 2 rows. And then I'm going to see if I can if I keep adding 1 to each row, if it would equal 8. And this is a strategy you could use if you're just not sure. If you know automatically, you don't have to do this, but it's still good, just fun and good practice to work with your manipulatives. That worked. So how many rows do I have here? I have 2 rows. And how many in each row? 4. 1, 2, 3, 4. It says you draw it though, so now I need to draw that rectangle that I created. So I have 2 rows, so I'm going to put 1 line down the middle to make those 2 rows, and then there's 4 in each row. So if I want 4 in each row, I'm going to make how many lines coming down? 3, right? 1, 2, 3. And that gives us 2 rows times 4 in each row, which equals 8. We did it. Super job, boys and girls. I hope you had as much fun as I did today. I think Erie is a lot of fun, especially when we're working with our manipulatives. And it just gives us something kind of a hands-on activity to use. Okay, so our lesson today was we were decomposing and recomposing shapes to compare areas. We definitely did that. We had on the front, we had the 12 square units, and we put them together and then we took them apart and made a bunch of different ones that equaled 12. So super job today. Keep up the great work, and I will see you all tomorrow.